Last time we have done with 5.2, and today we will start 5.3. And in this 5.3, I think last time I asked you to memorize group 2. Group 2 is double angle formulas. And those are the first one, part A, cosine 2A equals to cosine squared A minus sine squared A. The second variation, that's 2 cosine squared A minus 1. The third variation is 1 minus 2 sine squared A. The second one is sine 2A equals to 2 sine A cosine A. The third one is tangent 2A is tangent 2 tangent A over 1 minus tangent squared A. Now, let's do problem right away. Since I assume you already memorized it, let's do a problem. Suppose, for example, sine theta equals to negative 3/5, where theta is in quadrant 3. Now let's get the cosine and tangent first. Okay, let's get the cosine and tangent first. Now, suppose I have a right triangle. Well, the theta is in quadrant 3, so I cannot use theta here. I can only use theta head, right? Sine theta head to make it into an angle that we can apply that to right triangle. So sine theta head will be 3/5. This is 3, this is 5. So this must be 4 here, right? So cosine theta head is 4/5. Tangent theta head is 3/4. Okay. Then using these, we go back to theta. So what is cosine theta?
-4/5.
Why negative?
Because it's in the third quadrant.
In the third quadrant. How about the tangent?
It's positive.
Why?
Because it lives in the third quadrant.
That's right, because theta is in quadrant 3. Okay, now then from here we can answer the following question. How about cosine 2 theta? Cosine 2 theta, you have 3 variations. Okay, we can use any one of them. But if you happen to be not able to get this thing here, suppose that you didn't have a chance to get all these things here, then the best one for you is to use the third variation because you have the sine. Okay, so this is 1 minus 2 sine squared theta. That's 1 minus 2 times negative 3t squared. So that would be 25 over 25 minus 18 over 25 equals to 7 over 25. Okay. But if you say, you know what, Thomas, can I use 1a? Yes, you can. If you want to use 1a cosine 2 theta equals to cosine squared theta minus sine squared theta, then that's fine. The problem is you need to make sure that your cosine theta is correct. You see what I mean? If you get something different from negative 4/5, then you basically just use that question, right? Okay, this will be 16 over 25 minus 9 over 25. That's still 7 over 25. So you can use two different methods to do that, okay, for cosine 2 theta. Now, how about part B? Sine 2 theta. Can you do that? And part C, tangent 2 theta. Okay, I'll give you maybe 2 minutes, 3 minutes. So this is equal to 2 sine theta cosine theta. That's 2 times negative 3/5 times negative 4/5. That's positive 24 over 25. Actually, before we answer part C, I would like to ask you this question. Based on what you see here, this angle 2 theta is in which quadrant?
Quadrant 1, because they're positive.
Yeah, because sine and cosine both positive in quadrant 1. Okay, now let's go back to that tangent 2 theta. This is 2 tangent theta over 1 minus tangent square theta, which will be 2 times 3/4 over 1 minus 3/4 squared. That's 3 over 2 big over 1 minus 9 over 16. Multiply the top and the bottom by 16 will give me 24 over 16 minus 9. That's 24 over 7. Okay. Now we can also do part C alternatively by writing it as sine 2 theta over cosine 2 theta. We happen to know them already, right? So this is equals to, what is my sine again? Sine 2 theta, 24 over 24 over 25. So I will use the method to find tangent to theta using the first method there. Okay, if I don't know cosine to theta or sine to theta, but if I have known them, I can just use them. Okay, I can just use sine to theta 24 over 25 and cosine to theta 7 over 25. Multiply the top and bottom by 25, give me 24 over 7. Okay, same thing we have here. Okay, that's not really that fun so far, but you have to memorize those formulas. Okay, now just for, if we want to find, let's say, what is secant 2 theta, then before you answer secant 2 theta, you do it aside, you answer first 1 over cosine 2 theta, which we already know. Cosine 2 theta is 7 over 25, so this must be 25 over 7. Okay, now that's why we don't need the formula for secant 2 theta. We don't need a formula for that. Just work it out as using the reciprocal, or the reciprocal idea from the basic property. Okay, because we already have cosine 2 theta. Okay, now next one. Suppose I want to do another example, this time about graphing. Graph y equals to 2 minus 4 sine squared x. We never graph sine squared x, but we can do it this way. You factor the 2, right? Okay, and then you get 1 minus 2 sine squared x, but what will that be? That's cosine 2x, right? 2 times cosine 2x. Okay, now from there, then we go on. What's the center?
0,
What's the amplitude?
2,
So the range will be
-2 and 2.
okay, then how about the period?
Is just pi.
Right. How about the phase shift?
There's no phase shift.
Phase shift. So when we sketch the graph, approximately, this is just approximation. That's a cosine, huh? So I start from the top, go to the bottom. Approximately like this. Okay, so this is 0, this is 2, this is 0, this is pi over 2, pi over 4, 2 pi over 4. Now, that's the easy one, though. That's the easy one. Okay, that's the easy one. Let's do some proofing. So that's about graphing. Let's do some proofing. I happen to need you to memorize these 2 things here. 2 things. The first one is number 39. Number 39, you need to, in some sense, memorize this. Cosine squared theta equals to 1 plus cosine 2 theta over 2. Okay? We need to prove. Now, to prove this, we go from the right to left. You may wonder, Thomas, why we go from right to left and not from left to right. The reason is we have the formula for this guy. Oops, sorry, not that one. We have the formula for this. Boom, here. Okay, so I will expand that part later on. This is equal to 1 plus, there are 3 variations for that formula. Which one do I use?
B.
The second one, okay, the second variation, 2 cosine squared theta minus 1 over 2. Now, if you ask me, Thomas, how do we know that we will use that one? Well, because all this formula here only involves cosine 2 theta and cosine theta, right? So I will change it to only cosine theta version. Okay, now then, from there you notice that 1 minus 1 is 0, right? So I get only 2 cosine squared theta over 2, which is cosine squared theta. That's our left-hand side. That's the end of the proof.
Question.
Mm-hmm.
Even though it's better to use 1B, are you still able to use 1A and 1C?
Yes, yes, but it will be harder. Yeah, it will be harder. Let's see. Suppose I use 1A, it will be 1 plus cosine squared theta minus sine squared theta. Right? And then I will play with this. So originally I break it up this way. Okay, and then I do this. I do 1 minus sine squared theta. You see what I mean? That
Yeah.
1 minus sine squared theta is what? Cosine squared theta,
Yes.
right? Now then from there I will get this. If you use the third method, the third variation, that will be 1 plus 1 minus 2 sine squared theta over 2, which is 2 minus 2 sine squared theta over 2, and then you factor the 2. Right? And then by Pythagorean identity, you get 2 times cosine squared theta over 2. That's cosine squared theta. You see what I mean? So we have 3 different ways to do this. Yeah, we have 3 different ways to do this. I don't just point it back there again. Okay. Now this formula will be used necessary in the next section, but for now, they have a name for this formula. Even though, I mean, I regret that we don't call this any group, but in some textbook they call this power reduction formula. Power reduction formula. For cosine squared theta. So if you have cosine squared, it's a square there, right? Now you want to reduce that to the power of 1, but if you reduce the power 2 becomes the power of 1, then you get double angle. Okay? Now, those are the proof. However, I want to show you the intuitive proof or informal proof. Let me use a light color. Informal proof. Now, notice that we have cosine 2 theta equals to 2 cosine squared theta minus 1. Right? That's group 2, number 1B. Now, move this one to the left. So it becomes 1 plus cosine 2 theta equals to 2 cosine squared theta. Right? And then divide the whole equation by 2. Then you will get 1 plus cosine 2 theta over 2 equals to cosine squared theta. Okay? You play the formula. You play with the formula. Now, the reason that most textbooks don't call that a special group, the reason that most textbooks don't call this a special group, because this is basically, this formula here, this power reduction formula, is basically a rewriting of the double angle formula. Okay. Now, if you kind of like able to memorize how this informal proof being played, it may be beneficial for you to kind of like have some idea about this power reduction formula. We use this a lot in calculus 2 though. We use this a lot in calculus 2. Now, number 40. Another proof, another power reduction formula is sine squared theta equals to 1 minus cosine 2 theta over 2. Now, let me ask you to prove this. Let me ask you to prove this. I give you 2 options. Actually, I give you 4 options. I give you 4 options. The first one you use B. I'm sorry, not B. The first option I let you use group 2, number 1, the second variation. or group 2, number 1, the first variation, or group 2, number 1, the third variation, or you modify informally group 2, number 1, the third variation. So basically, all those 4 are summarized with my black color, red color, blue color, and gray color. Okay, let me give you 3 minutes to prove this. Of course, I will not do all 4 anymore. Which would you like me to do?
A?
The A1, the first method?
Mm-hmm.
This one here? Okay. So the proof, I think for that one I used black color earlier. Okay. So using the first method here, proof from right to left, right hand side, we get 1 minus cosine 2 theta over 2. That will be 1 minus 2 cosine squared theta minus 1 over 2. That's 1 minus 2 cosine squared theta plus 1 over 2. Then continue here. That's 2 minus 2 cosine squared theta over 2. I will factor the 2. Cancel the 2, which will give me sine squared. Okay, that's the left hand side. Okay, now then let's do more proving. Actually, the next one is something you need to memorize also, and it happens to be in our textbook. Proof that tangent theta is equal to 1 minus cosine 2 theta over sine 2 theta. I would like you to try. I give you maybe 3 or 4 minutes, but the hint will be you go from right hand side. Okay, the reason is you can apply formula here and formula here. I know you may have issue with Thomas. I don't know which formula to use. Okay, for the cosine 2 theta, I don't know which formula to use. At least think this way. Think of a formula that helps you cancel that 1. Use the formula that helps you cancel that 1. Okay, so imagine 1 minus what minus what, such that you can cancel this 1 here. To cancel this 1 here, it has to be 1 here. Right? Okay, so you will expand your cosine 2 theta using 1 minus something. Okay, and the good news is later on when you distribute the negative here with the negative there, you end up with positive. That 1 minus 1 plus something. Okay, try it. Maybe 2 minutes is good enough. Right hand side equals to 1 minus cosine 2 theta over sine 2 theta. That's equals to 1 minus 2 sine squared theta over, how about sine 2 theta? What's that?
Sine theta, cosine theta.
2 sine theta cosine theta. Then on the top, when I distribute the negative, I get 1 minus 1 plus 2 sine squared theta over 2 sine theta cosine theta. And I will cancel the 1, right? I will continue here to save some space. So I get 2 sine squared theta over 2 sine theta cosine theta. Cancel the 2, cancel the sine. I get sine theta over sine theta, which is our tangent theta. That's our left hand side. That's the end of the. Okay. We will do more proof, but this time I need to guide you. So you do a little, I do a little. Okay. Number 46. Maybe number 44 first. Number 44 first. Why not? Number 44. How scared I will be when I see proof 2 cotangent to x equal to cotangent x minus. Honest, we don't have formula for cotangent. So what should I do if I see this question? Two cotangent 2x. Now, we don't have formula for cotangent, but which function of double angle related to cotangent?
Tangent.
Related to tangent. So we can rewrite this as 2 over tangent 2x. Is it right?
Yes.
Okay, now then we use the formula tangent 2x will be, so this is a big line here, 2 tangent x over 1 minus tangent x. Then furthermore, this is equal to, let me multiply by the reciprocal. So this will be 2 times the reciprocal 1 minus tangent squared x over 2 tangent x. Okay, so I hope you can see this is my numerator divided by the denominator. That's multiplied by the reciprocal. Right? Multiplied by the reciprocal. Okay. Now then, let me continue here. What do you think you will do?
Right. Tan 2a. I mean, tan 2x.
Tan 2x?
Yeah. So would we write it as tan? Yeah, 2x. Like that?
Not yet.
Not yet.
Not yet. No, actually, we are not going here. We are not going here. We already wrote it as tangent 2x on the denominator. But how do we go on from here? So well, I'll give you a hint. You can cancel the 2. Right? Because this is 2 over 1. Right? So we have 1 minus tangent squared x over tangent x. Now what?
You have your cotangent x,
How do you get that?
reciprocal of tangent x.
Okay, but how do you get that reciprocal of tangent x?
Can you do 1 over tangent x minus tangent
That's right. We need to,
square?
yeah,
You
that's
split
what.
them.
We have to split them first. Okay, so you see it, other people cannot see it, right? Okay, so I split that first, then I say, oh, this is cotangent x, and this is tangent x. Voila, we all see what we want to see. Okay, yeah, so this is how we handle the situation when we don't have a formula for cotangent double angle, or earlier secant double angle, or cosecant double angle. We write it as a reciprocal, then we suddenly have the formula. Now, number 46. Prove cosine 3 theta is equal to 4 cosine cube theta minus 3 cosine theta. So we get double angle formula. Now this is triple angle formula, but don't worry, you don't need to memorize this. In fact, I don't want you to memorize it. I need you to be able to prove it. Okay, now you do it together with me. Cosine 3, we will prove from left to right. Cosine 3 theta. I will rewrite that 3 theta as 2 theta plus theta. Okay, and then I would like you to use formula 1, 1. After you're done with formula using formula 1, 1, then you will use formula 2, 1, 2, 2, 1b, and 2, 2. And then you will need to use B21. Okay, if you don't know what those are, just work it out first. Basically, what you need to do next here is to use some cosine of sum formula. Okay, and then apply that to double angle formula for cosine, double angle formula for sine. So this would be cosine 2 theta times cosine theta minus sine 2 theta sine theta. Now then for cosine 2 theta, Thomas, cosine 2 theta has 3 variations. How do you know that we use the second variation? Well, we know because all the expression here, the whole expression here is in terms of cosine. So I need to rewrite it in terms of cosine. Okay? That will then be 2 cosine squared theta minus 1 cosine theta. That's for the first term. Minus, what is the expansion of sine 2 theta?
2 sine theta, sine theta.
2 sine theta cosine theta. Right? I will distribute. Let me distribute first. I will get 2 cosine cube theta minus cosine theta minus 2 sine squared theta cosine theta. The thing is, I already have the cosine cube term and cosine term, but I have this ugly sine squared here. I don't want this guy. I don't want this guy. I need to change this into cosine. How do I change that?
Pythagorean identity?
Which will be
The first one?
the first one. What is the first one?
Cosine squared theta plus sine squared theta equals 1.
Okay, so here I start with sine squared theta. So it becomes what? 1 minus cosine squared theta, right? And then you will distribute that. We get 2 cosine cubed theta minus cosine theta minus 2 cosine theta plus 2 cosine cubed theta. That will be 4 cosine cubed theta minus 3 cosine theta. That's the right hand side. Let's do one more proofing. Let me pick the hard one. Number 54. Prove that 2 minus 2 cosine 2x over sine 2x. This guy is equal to secant x cosecant x minus cotangent x plus tangent x. Okay, let me ask you to do that. You will start from left hand side though, but this guy here, you can use any one of them, but I think the best one, the fastest one will be use the original one, the first variation. You know what? Let me give you a break. At the same time you do this, we come back at so we will go from left to right. That's 2 minus 2 cosine 2x over sine 2x. Okay, which formula you use for cosine 2x?
No, I did it from right to left.
Huh? You do it from right to left?
Yeah.
That would be super hard.
Can we use the first one?
Yeah, I will use the first one. So this will be 2 times cosine squared x minus sine squared x over 2 sine x cosine x. I will distribute the 2 on the top. 2 minus 2 cosine squared x plus 2 sine squared x over 2 sine x cosine x, and then I will separate them. I will split them. 2 over 2 sine x cosine x minus 2 cosine squared x over 2 sine x cosine x plus 2 sine square x over 2 sine x cosine x. Now then we will simplify. The 2 here cancel, right? It becomes 1 only on the top. Now what will that be? So that will be 1 over sine x cosine x, right? While the 1 here will be the 2 cancels. Actually, one of the cosines also cancels, right? So what do I have left? Cosine x over sine x plus sine x over cosine x, which will give us secant x cosecant x, right? If you want to go a bit slower, you can do it this way. In case you don't see what I did, I will write it as 1 over sine x times 1 over cosine x. See? And this becomes cotangent x, this becomes tangent. So this guy becomes secant x, this is cosecant x, just to match with the pattern on the right hand side. Okay, I go further. The type of question you may not see in your textbook, but it's necessary. Let y equals to, let's say, 3 plus 2, maybe not 3 plus 2, 3 plus what? 4 sine square x. And the main question is to graph it. The main question is to graph it. But again, we never know how to graph anything with sine squared x though. What we can do, however, you remember that sine, if you remember, I don't think you do, okay, but I forgive you if you don't. But for the next meeting on Monday, you should remember this. 1 minus cosine 2x over 2. Remember that? That's something we did actually quite early. Let me show you where is that. This one. Okay, the power reduction formula, right? Okay, so that's what I will use here. So y equals to 3 plus 4 times 1 minus cosine 2x over 2. That's y equals to 3 plus 2 times 1 minus cosine 2x. This is 3 plus 2 minus 2 cosine 2x. This is y equals to 5 minus 2 cosine 2x. And from there, I don't think I will actually graph it, but let's get the idea. Center is
5,
the amplitude.
2,
So the range will be
3, and 7.
3 to 7. How about the period?
Pi,
2 pi over 2, which is pi. That's right. How about the phase shift?
There's no phase shift.
No phase shift. Okay, then we are able to graph this already, right? So the key step is really to convert that into a form or a function that we recognize. Okay, now once we write that in as a function that we recognize, that we can find what's the center, the amplitude, the period, the phase shift, right? Once we get that, then we will be able to get this information, therefore we will be able to graph. Okay, the ability to graph is something I assume you should be able, you to be able to do. Okay, your suggested homework from here will be 5.3, number 1 to number 53. Just do the odd ones. Always just do the odd ones. Okay, now that's for 5.3. I'm going to go over 5.4. In this 5.4, we will have group 3, half angle formula. Okay, group 3, you need to memorize this. First one. The first one, cosine theta over 2 is equal to 1 plus cosine theta over 2.
Professor, it's 5.4 for half angle.
Oh yeah,
formula.
thank you. I wrote 5.4, but I write 5.3. It's 5.4. That's the first formula. The second formula, sine theta over 2 is equal to 1 minus cosine theta over 2. Oh, you know what? I forgot something. Plus minus square root. Plus minus square root. And the third formula, the first variation, we don't really use this, but I write it down anyway. That's plus minus square root of 1 minus cosine theta over 1 plus cosine theta. The second variation for tangent of half angle is 1 minus cosine theta over sine theta. And then the third variation for tangent half angle is sine theta over 1 plus cosine theta. I will prove all 5 of them, okay? But just like before, you need to memorize it in this order. Now, I hope at this point you already understand why I need you to memorize in this order. Because when we quote that, I will just quote the coding. For example, 3,1 refers to the first formula. Okay, this is 3,1 here. When I say 3,3b, 3,3b refers to this one. Okay? Now, how about the proof? Proof. From power reduction formula, we have that cosine squared A equals to 1 plus cosine 2A over 2. Thomas, I don't remember that. Okay, don't worry. Let's look back to 5.3. Okay, in 5.3, when we talk about power reduction formula, here. Remember this? Okay, I just changed the theta becomes A here. Or that's the formula. Okay, that's the formula. Now, here's the trick though. I will say let 2A equals to theta. Yeah, basically this guy is twice of this. Therefore, we can say that A is equal to theta over 2. Okay, now let's rewrite that. Then it will be cosine squared theta over 2 equals to 1 plus cosine theta over 2. I just do that substitution. I call that 2A to be theta. Now then cosine theta over 2 now becomes plus minus square root 1 plus cosine theta over 2. Okay. So similarly, from what we saw from in 5.3, sine squared A is equal to 1 minus cosine 2A over 2. Using the same substitution, we get sine squared theta over 2 equals to 1 minus cosine theta over 2. Then I do square root both sides. And I get plus minus square root of 1 plus, oh, I'm sorry, 1 minus cosine theta over 2. That's the end of the proof for the second statement. Okay, for 3A, tangent theta over 2 is equals to, by definition, sine theta over 2 over cosine theta over 2. That is plus minus square root of 1 minus cosine theta over 2 divided by plus minus square root of 1 plus cosine theta over 2. Basically, I use the formula from the second and the first. Going further, plus minus, we don't know if plus or minus, we keep it plus minus here. Okay, and then inside we will get 1 minus cosine theta over 2 big over, let me pull it down further, one plus cosine theta over 2. Now multiply inside the radical by 2 over 2 to get rid of the complex fractions. I get what I need. That's plus minus square root of 1 minus cosine theta over 1 plus cosine theta. Okay, that's the end of the proof for 3a. Now, the first three formulas here has the plus minus sign, which means we need to adjust this guy here, okay, need to adjust with the quadrant. Okay, I will leave the proof for 3B and 3C much later. Okay, I will leave the proof for 3B and 3C much later, but let's do some example first. Let's do some example first on how to use all these formulas here. Suppose, for example, we have let cosine A equals to negative 3/5, and A is in quadrant 3. And our question is, we need to find what is cosine of A over 2. And how about sine of A over 2? Okay. And for the tangent, oh yeah, we can do that too, but you see that if we get these two, we can get the tangent really fast, right? Okay, now here's the thing. Unlike in other case, like in the past, we have cosine 2a, sine 2a, and then from there we decide. So we need to find cosine 2a and sine 2a, and then from there we decide this 2a in which quadrant, right? That's what we did at that time. Now, right now, actually, we don't need that. Right now, we don't need that. What we will do is, instead, because A is in quadrant 3, it means A must be between what angles? It must be between 270 degrees to 300, I'm sorry, quadrant 3, 180 to 180 degrees to 270 degrees, right?
Yes.
Okay, now then, if we divide by 2, then we also divide the other two sides by 2. Agree? Now, but because A over 2 is between 90 to 135, it also implies this A over 2 must be between 90 to 180. Is it right? It means A over 2 is in which quadrant?
Quadrant
Second
2.
quadrant?
Quadrant 2, that's right, second quadrant. Okay, now then from there later on when we answer part A, cosine A over 2, in quadrant 2, cosine is negative. You see what I mean? According to the formula, it should be plus minus. right? But I say that the reason we put plus minus there is because we need to adjust with the quadrant first. You need to know where is this theta over 2, which quadrant is theta over 2 located. You see what I mean? Okay, so that's what I did here. That's what I did here. I need to find first where this a over 2 located, and then from there I know for the cosine of a over 2 it has to be negative. Okay, and then this is 1 plus cosine a over 2. This is equal to negative square root of 1 plus negative 3/5 over 2. Going further, this is negative square root of 2 over 5 big over 2. Okay, so if you add the top, you will get 2/5, right? And then this is square root of negative square root of 2/5 multiplied by 1/2. That's negative square root of 1/5, which is negative of 1 over square root of 5, which is negative square root of 5 over 5. If I multiply by the square root of 5 over square root of 5. Okay, that's just to rationalize the denominator. Now, can I ask you to try doing part B? What is sine a over 2? Now, the formula should be plus minus square root of 1 minus cosine 2, I'm sorry, cosine a over 2. However, from the quadrant we know sine is, the theta is, the angle is in quadrant 2. So sine of that theta will be
Negative.
the sine.
Oh, the sign positive.
Okay, it will be positive. So we use the positive branch, then you plug that in and try to simplify. Okay, let me give you 1 minute for this. Okay, that's how we get for part B. Now, of course, if we want to find the tangent from here, tangent A over 2, we can just use part A and part B. Okay, we can just use part A. You can use A and B. In fact, that's what I will do. Now, however, if you say, you know what, Thomas, I want to use formula. If you want to use formula, now tangent in quadrant 2 is negative square root of 1 minus cosine A over 1 plus cosine A. 1 minus negative 3/5 over 1 plus negative 3/5. This is 8 over 5, big over 2 over 5. Fast forward, you will see this is equals to negative. That's for the algebra. Now, you need to memorize the formula. Don't get me wrong, you need to memorize the formula, okay? You need to memorize the formula. Now, I'm about to show you what happened with part 3b and 3c. Okay, now for part 3b, proof 3b, that is tangent a over 2 equals to 1 minus cosine a over sine a. And the proof is using a result that we have before. From an example in section 5.3. We have tangent theta equals to 1 minus cosine 2 theta over sine 2 theta. So I basically do the same substitution. Okay, let 2 theta equals to a. So theta equals to a over 2. Okay, I'll then put it in. So tangent a over 2 equals to 1 minus cosine a over sine 2a. I'm sorry, sine a. That's it. That's the proof. Okay, I just do substitution. That's it. Okay. The harder one is how about the proof 3c. Tangent a over 2 equals to sine a over 1 plus cosine a. Now notice that the good thing about these two formulas here, tangent a over 2 and for 3b and 3c, the good thing here is we can get the values without deciding which quadrant they are located. Okay, as long as we know sine a and cosine a, we are actually able to do this problem. Find tangent a over 2 directly. Okay, now here's the proof. From left to right, tangent a over 2 according to 3b is 1 minus cosine a over sine a. That's what we proved just now. Now then what I will do is I will multiply by the conjugate on the top and the bottom. Okay, the conjugate of the top is 1 plus cosine a. Now then on the top, the reason I do that is because I want to get difference of squares. While at the bottom, I will just leave it like that. I don't need to distribute. I just multiply them together like this, but I don't need to distribute. This is equal to sine squared a over sine a times 1 plus cosine a. That's sine a over 1 plus cosine a. That's our right-hand side. Now, once we get the formula, half angle formula for sine, cosine, and tangent, then the reciprocal gives us the half angle formula for secant, cosecant, and cotangent. Let's do one more problem similar to that. Let's say I use, what is this? I actually don't know what I really want. Let secant B to be 3, D is in quadrant 4. Now, if B is in quadrant 4, so the first question I would like you to answer, where is angle B over 2 located? Okay, and then from there, I would like you to compute, for example, sine of B over 2. Okay, and how about cotangent of B over 2? Now, let's answer the first one. B is in quadrant 4. It means B must be from what angle to what angle?
360 to 270.
270 degrees to 360. And then when I divide by 2, that will be between 135 degrees to 180 degrees. So from there we see B over 2 is in which quadrant?
Third quadrant?
It will be, no, I don't think so.
No.
I don't think so. Because then if you see it better, it's less than
Second.
180 degrees. That's right. It's between 90 to 180. Right? So B over 2 will be in quadrant 2. Okay, now then, what happened to sine B over 2? B over 2 is in quadrant 2. So what will the sine be? Plus or minus?
Plus.
That will be a plus. We usually don't write that sign though, but let me write it here so that you are aware that I don't forget. It's simply because it's positive. Later on, I won't write it. Cosine B of 2. Uh-oh, hold on. But I don't have cosine B though. Okay. Secant B is 3. So what will cosine B be? Don't think too hard.
One over 3.
That's right. It's 1 over 3. Okay, now that's what I will use here. This is 1 minus 1 over 3 over 2. 1 minus 1 over 3 is 2 over 3 divided by 2. That's square root of 1/3. That's 1 over square root of 3. Square root of 3 over 2. And how about part C? Cotangent of B over 2. Now, this is 1 over tangent B over 2. Okay, now then I use one of the formula for B over 2. let's say I use that one, sine A over 1 plus cosine A. Let me use that. Therefore, this will be basically the reciprocal, right? That's 1 plus cosine A over sine A. I know cosine A. We did that earlier, right? I know cosine. I'm sorry, that's not A. It's B. Da-da. I don't believe in evolution until this happens. We call that mutation, whatever comes. Okay, cosine B is known to be 1/3, but how about sine B though? Will sine B be positive or negative?
Positive.
Do you know?
1 and 2.
Huh? No,
1 and 2.
that's B over 2. What is sine B, positive or negative?
Negative.
Negative, because it's in quadrant 4, right?
Yes.
Okay, so this will be negative. Okay, now then, kind of like imagine the triangle, or if I were you, I would draw it. Cosine B hat, if let's say this is B hat, is 1/3, this is 1, this is 3. So this will be, by Pythagorean theorem, this will be 2 square root of 2. Okay, so sine B hat will be 2 radical 2 over 3, and because B is in quadrant 4, that will be negative. Okay, that's what I will use here. This is then equal to 1 plus 1/3 big over negative 2 radical 2 over 3. Okay, so I set the stage there. But once I set it up right, I multiply by the LCD to help me simplify that a bit faster. So I get 3 plus 1 over negative 2 radical 2. That's negative 4 over 2 radical 2. Multiplied by radical 2, the top and the bottom. I get negative 4 radical 2 over 4. That's negative 5. Okay, I will do one more computation problem, and then one proofing problem. And then after that, I let you go. One computation problem. If you have your textbook open with you, choose which would you like me to do, number 32 or 34 or 36. Okay, number 36. Nobody say anything. Number 36. Sine 105 degrees, and we use half angle formula. Okay, so this is sine 210 degrees over 2. Okay, now because 105 degrees is in quadrant 2, so sine is positive, right? That's in quadrant 2, so sine is positive. That will be square root of 1 minus cosine 2tan degrees over 2. Now this is equals to square root of 2 cosine 210. That's in quadrant 3, so that's negative. The reference angle is 30 degrees. That's 1 plus cosine 30 degrees over here. That's equal to square root of 1 plus radical 3 over 2 equal to 2 multiplied by the LCD. Get 2 plus radical 3 big over 4, which then give me 1/2 times square root of 2 plus just to remind you that we can compute this sine 105 happens to be using another method. We are able to compute sine 105 degrees by using sine 60 degrees plus 45 degrees. I wonder if you remember that. Sine 60 degrees cosine 45 degrees plus cosine 60 degrees sine 45 degrees. That is square root of 3 over 2 times square root of 2 over 2 plus 1/2 square root of 2 square root of 6 plus square root of 2 all over 3. Okay, so basically the value that we have here is the same to the value that we have up there. I'm sorry, not over 2, it's over 4. It's over 4. There's a typo there. Should be over 4. Okay, just to remind you about that. How about some proofing? You look at the proofing problem.
So wait, question. So if this comes out on the exam, and you said they're about the same value, we could use either method?
If I don't say using which method, then you can use either one.
Okay.
But I usually say if compute using half angle method, then you have to use the first method here. Is it okay?
Okay.
Let's think about the following question. The question that you cannot use other method but half angle method. For example, if I want to compute tangent 67.5 degrees. Now, this angle here is not doable by other method, but half angle. This is tangent 135 degrees over 2. Okay. However you add or subtract those special angles, it will not give you 67.5. You see? Okay. Now that 105 degrees that we had earlier happens to be 60 plus 45, right? So we are able to use the second method, you see? Okay. However, the second method doesn't work for the last question here, the last example here. Does it make sense?
Yeah.
Okay. But then this can be done by 1 minus cosine 105 degrees over sine 135 degrees. Okay. I basically use free C or B. I think it's B. Okay. There, cosine 135 degrees is negative cosine 45 degrees, and sine 135 degrees is quadrant 2, reference angle 45 degrees. So that is 1 plus radical 2 over 2, big over radical 2 over 2. Multiply by, on the top and the bottom, by radical 2. Actually, you should just multiply by 2. But if you happen to see it, I will multiply by radical 2. Okay. The reason is, then what happened at the bottom? What happened at the bottom? I have radical 2 times radical 2 is what? That's 2, but still divided by 2, right? So that's radical 2 plus 1 over 1. That's radical 2 plus 1. Okay, let's see more. How about the proofing? Which question you want me to do? Don't do number 48. Number 48 is something you can do using. You don't need to use half angle formula. Maybe I'll write it down. For number 48. Number 48. Use power reduction.
44.
44. Okay, seems to be interesting. Number 44. Oh, by the way, it reminds me that I did ask question number 44 in one of my tests. Prove that tangent x over 2 minus cotangent x over 2 equals to negative 2 cotangent x. Okay, proof. Of course, we have to prove from left-hand side. Tangent x over 2 minus cotangent x over 2. Now, don't make it sine cosine. I'm sorry, don't make it sine cosine. You have tangent and cotangent. What do? Make it into tangent. Is it okay? But then, later on, when you use your formula, okay, we try to use the formula that is more effective. Try to use the formula here, the one here. Use the formula that have only one term on the denominator. Which one? 1 minus cosine x over sine x minus. Now then, I will not use the same formula for my tangent here. Okay, I can use the same formula, but it will get a lot harder. Instead, I try to find a formula. I try to use the formula that has sine x on the top. Why? Because I will do the reciprocal later on, and all of a sudden I have common denominator. Do you see my plan?
Use the reciprocal.
Yeah. Then in the next step, I do the reciprocal, right?
Yeah.
And then you combine like terms, a common denominator, right? So you put them together, you'll see the 1 cancels, right? But then we get negative 2 cosine x on the top, sine x at the bottom, blah, blah, blah. Okay, you can fill up the details. I will stop here. Your suggested homework from this 5-4 is number 1 to number 47. Number 1 to number 47. Maybe if I were you, I will do this. If I were you, I will do, instead of doing all those, I recommend you to do number 1 to, and then number 3. Okay, and then 9, 11, 13. Okay, that's actually one set. And then number 15 to number 25, of course, it's just the odd ones. Number 31 and number 33. As for the proofing, number 37 to number 47. Okay. Yeah. So basically, you skip number 5 and 7. Number 27, 29, you also skip there. Okay. This way, you are not too heavy. Okay. So on Monday, we will work on 5.5 and 6.1. On Monday, we will work on 5.5 and 6.1. The next thing is for 6.1, it is independent of 5.5. Okay, so maybe I write it here. Section 5.5 and 6.1 are independent. I can do either one of them first. In fact, I may do 6.1 and 6.2, and then on Wednesday next week, I do 5.5. But I don't think it's a good idea. Yeah, I will do 5.5 and then 6.1 on this Monday. And then on Wednesday next week, I will do 6.2, 6.3. Okay, they are actually quite similar. So 6.1, 6.2, 6.3, they are actually quite similar. Okay, okay. See you then next week.
Bye, Professor. Thank you.
You're
Thank
welcome.
you.
Bye.